to my introduction to machine learning and investigating the concept of heart failure, um, basically with my partner Ishmael Ibudo. We looked at a Kaggle data set of described indicators and clinical information that may cause heart failure. I'm not a doctor, but this was a great exercise to kind of understand what insights we can get through using correlation and classification tools learned in machine learning. So the key data analysis tools that we use for our Python data and analysis was correlation via Pearson correlation and Spearman's correlation, and then also classification modeling, which focused on a training test data set, looking at different types of classifiers. One is the logistic regression, which employs kind of binary to an event that happens, which in this case is AHD, which is heart disease, and then translating that into something that we could investigate more with the information that provided from the CSV file from Kaggle, and looking at decision tree modeling, random forest classification, in K nearest neighbor. First, we use the data tools via Python library scripts. What I'll be focusing on is my personal outlook on machine learning that kind of focuses on form, fit, and function. The form of the data in terms of data quality, and so on and so forth. Next slide. Insights are really important. Again, I mentioned data quality. We're going to look at data from a pattern recognition standpoint when it comes to the direction of the information and also the density of information that's brought in to classify and to also understand how the information in terms of continuity looks. And then training data sets, of course, specifically on the event or the objective function. I'm going to focus in terms of conclusions, in terms of what models work best from an accuracy standpoint and why, and then optimization when it comes to getting insights that are not really at steady state, which would be an onset of something that could be physically impairing to an individual from the information provided. And then things to think about in terms of time varying effects and what models could work best. So with data quality, when I bring in the data set, it ranges from about 12 different parameters when it comes to the inputs. And then I'll focus on the definition of those, but importantly, what outliers in terms of null values that exist to cross out certain data entries, and then the categorical values to understand how well we can classify the outcome of AHD from a certain specified set of information that's inputs. And then also from a variation standpoint, from a box plot view, what that information may or may not look like when it comes to classification. So with data correlation, we use Pearson's correlation and Spearman correlation. Again, giving some brief descriptions of some of the inputs ranging from blood sugar, electrocardiographic performance, heart rate, exercise-induced inflammation, age, certain target parameters that identify uniquely to AHD. If you look at Pearson's correlation here, we show that there's a range of interactions between the parameters from a linear perspective, but obviously there could be potentially higher order effects that may not be so well categorized by this data set, but can linearly be described from a constant perspective if there's a change in the output Does the corresponding change either be a V-score or, Z-score, if it coincides with the direction of change of the event, which is heart disease. So starting off with a sense of pattern recognition, I call it kind of loosely pattern recognition, but if you look at the distributions of each individual input in terms of density, in terms of volume as well, kind of the same, but in terms of frequency as well. You can tell that from the 14 inputs, output is actually the target AHD, so 13 inputs. You can see age, TRT, BPS, and THLACC, LACHH have high density distributions, which would lend itself to be strong predictors for AHD. Just uniquely specific to the type of information that came in, the volume of information that came in that distribution. The more unique the aspect of each parameter, the best it will fit different types of outcomes, i.e., even though we're at zeros and ones for AHD, I would still think the ones that are highly unique over a broader variation of inputs would actually be higher drivers of accuracy with any linear model. So with the classification results, again, we looked at logistic regression, decision tree classifier. We also looked at random, let me go further a little bit, random forest classifier and the k-nearest neighbor. For the logistic regression, because it is designed to be the type of signal we're looking at of zeros and ones, I would imagine that accuracy to be best logically, which it proves true. The decision tree is kind of based off of more of a hierarchical model. So I would think it would kind of rank in the top 3. Moving along with the other two, the random forest classifier, because it's random and it doesn't start with some biased initial condition, I would think because it's a random model that it would probably perform in the higher 3, which it does. And the k-nearest neighbor is relatively one of the lowest, primarily because it focuses on some mean and then basically walk in an optimal standpoint to reduce the overall bias of each parameter to the outcome, but it classifies at the lowest in terms of the overall classifications used from Python scripting. So in conclusion, the logistic regression performs best, random forest at 2nd, decision tree at 3rd, and k-nearest neighbor at 4th. What I would kind of think in long term, if we were to look at the distribution of AHD more in not a logistic standpoint as zeros and ones, but something that's a lot more variable, I would imagine we would use something that's more time intrinsic as well, specifically like a common filter that you can utilize biases and tuning to look at outliers, whether it be at the high frequency or the lower frequency, to get onsets of AHD, which may not be captured here. This concludes my presentation. I hope you have a great day. Bye.